and welcome dear future computer architect. I am Nikita Vinay, super thrilled to be your guide throughout this computer architecture series at nikhiskilltech YouTube channel. This is the very first session of the entire series and we'll be covering the first unit or the first chapter based upon different university syllabus. Wait a minute, did I say universities? Yes, of course. This series is gonna be a lifesaver for any candidates from any different universities who have computer architecture subject in their syllabus. That might be BSc, MSc, MCA, BCA, BE or any other computer science department. In today's class, we are going to understand about the basic structure of the computer architecture, where we will be looking after the main memory, central processing unit, input output unit, and also how they perform. In today's class, we are going to have a look after the structure of computer architecture, how the data enters the computer, how the user fetch the output. Also, during this process, how the data is transferred, processed, and also the output is produced. We will be going to have the detailed knowledge about this entire computer architecture structure. And also, which are all the topics that we are going to cover on today's session is: number one, the basic of computer architecture, the memory management and the central processing unit, instruction set architecture, process design, and benchmarks and matrices. On here, we will understand how the von Neumann architecture works. Who is von Neumann? John von Neumann is a famous mathematician, also physicist, who has proposed the von Neumann architecture for computer architecture. Later on, based upon this, the modern computer architecture was designed, proposed, also worked on. So this was introduced by John von Neumann in the year of 1945. Now let us understand the structure of computer architecture. So this is the basic structure of a computer architecture, where the computer will be holding a main memory, central processing unit, input output unit. Also, inside the central processing unit, there will be three components called arithmetic and logical unit, registers, and control unit. How does actually this von Neumann architecture work? Let us understand it now. So, user will pass the instruction or a task to the computer using input devices. This instruction will be received by main memory, which is the slowest memory to work on. So, this main memory doesn't understand how much the data holds the capacity. So, it will directly pass the data into central processing unit. Central processing unit will analyze the data and will start processing it. So this will analyze whether the data belong to the arithmetic and logical operations. If the data belongs to the arithmetic and logic unit, it will start processing inside the arithmetic and logic unit, which is little faster than the main memory. If it is not belonging to the arithmetic and logic unit, that is not belonging to the mathematical operations, then it will directly pass the data into control unit, which will manage the execution of a data. Also, it will help for data flow to the input output unit. But during this process, the control unit holds certain capacities. If the data length exceeds the capacity, the speed of the data processing requirement will also be increased. So now the control unit need another unit which is more effective than the control unit, which will speedily access the data, will process the data, and will flow the data to the input output unit, which is none other than register. Registers are the fastest ever storage capacity holders, also the processing unit inside the CPU, which will receive the higher length capacity data inside it, and it will start processing it, and it will produce the input output through input output devices. We have understood that main memory have a slowest capacity than the CPU, so it will directly flow the data into CPU for processing it and analyzing it and producing the input and output. But what if the main memory have a certain capacity and the data is within that capacity? The data will again get back to the main memory from the CPU itself. The central processing unit will pass the data again back to the main memory, and the main memory will process the data and will produce the output, the user directly. And remember, this main memory is always a temporary memory. So during this process, whatever the connectivity you have seen in between the main memory, central processing unit, also the input output unit, these connectivities are also called as communication channels or communication systems, and commonly known as bus topologies. So these buses helps the data to transfer from main memory to central processing unit to input output devices. Hoping that you understood until here. You have got the entire structure, how data flows, how it works, how it been processed, also how the input output been produced. So let's move on to the next slide. It is main memory. As I already said, it's a temporary memory. The main memory refers to the primary storage area that the CPU accesses directly. It is also known as RAM, not RAM. It's RAM, random access memory. So the main memory holds the data that CPU is currently processing or will process soon. So it's currently processing or it will be processed soon. Also, it is a temporary memory. We cannot blame the main memory if the data is being lost. It's our responsibility to save the data during this process. So that's why always the mentor says keep pressing Ctrl S while you work on computer. So this is how the RAM actually looks like. You can observe RAM in the CPU. Nowadays CPUs are not there. This will be directly fixed inside the motherboard itself. So moving on to the next slide, CPU. So this is how the CPU looks like. The CPU stands for Central Processing Unit. How much the brain is important to the human being, the same way the CPU is for computer system. Nowadays, as I said, we don't have a CPUs, but we can purchase the CPU as additional. Nowadays, the computers comes with a built-in CPU system. So it is often considered as a brain of a computer. Point to be remembered, it's a hardware component. Wait a minute, what is hardware? A hardware is anything we can touch, feel. For example, this mouse, monitor, pen drive, mobile phone, everything which we can touch and feel. Okay, we came to know it's a hardware component, but what is software, by the way? Software is nothing but we can use without a physical touch or physical handling. It's, for example, it's a music, PDF, applications, OS like operating systems, etc. We can feel it, but we cannot touch it. Those are all called as software. So it's a hardware component that interprets and executes instructions in the computer. The CPU performs basic arithmetic and logic control input-output operations specified by the instructions in a computer. Okay, we came across instructions. What is instruction now? Instruction is a command or a method of execution. Command which we give to the computer. Okay, we also have seen something like program. What is program now? It is a set of instructions again, set of a commands, set of a mode of execution. So whichever the command we give or whichever the task we give to the computer are considered as program. So set of a instruction to perform a particular operations. So for example, if I say the computer to perform basic operations like addition, or it will perform the addition by using plus symbols. So it have to get to know that whether it belongs to the arithmetic logic unit or a control unit, or the bandwidth of a data is higher, so I have to pass it to the register, or it is more comparatively less, so I have to pass it back to the main memory. The CPU will understand it. So we came across the CPU, but now we have to see the components of a CPUs. The components of a CPUs are arithmetic and logic unit. As I already said, it will understand whether the data belongs to the mathematical functions like arithmetic logic units, etc. And control unit will manage the executions. Registers are the high-speed memories that will process the data faster than main memory or arithmetic logic units. And finally, we got cache memories. Cache memory is faster than the register memories. Also, it is a temporary memory. We often clear cache memories in our mobiles also. You got my point, I guess. So cache memories are temporary memories, but it got a highest speed than main memory, registers, also arithmetic and logic unit. Now moving on to the next slide, we will understand the definitions of registers. Registers are small and high-speed storage locations within the CPU that holds the data temporarily during the execution of instructions. They are fastest type of a memory in a computer systems, are located directly in a CPU chip. Registers are used to store the data being processed by CPU and hold the intermediate results of calculations. So registers are also a temporary memories which is faster than the main memories. As I already said, these holds instruction registers, program counter, memory address registers, memory data registers, accumulators, index registers, stack pointers. We will know about these registers in detail in the next chapters. Now coming back to the control unit, it is an essential component. It helps in managing execution of a program. The primary function of a control unit includes instruction fetch, instruction decoding, execution, control flow, data flow, also data store. We have to know about this. Instruction fetch is something the CPU receives the data from the user. Fetch from the users, the data fetched from the users. Decoding, it will understand which category the data belongs to, whether the arithmetic logic unit, control unit, or the registers, or else coming back to the main memory for a temporary storage. Later on, it will execute the program. It will control the flow of data from input to output unit and also for the user monitor. Later on, it will also help in storing the data for future use. So data store. This cycle is also called as instruction cycle or a ISA. So this ISA cycle holds fetching the data, decoding the data, executing the data flow, also storing the data. And arithmetic logic unit, already I have told you, it will perform basic mathematical operations like addition, subtraction, multiplication, division, modular, and also the gate operations like AND, OR, NOT, NOR, etc. You will get to know this in detail in coming up chapters. So moving on to the bus. Bus refers to a communication system that enables transfer of a data between the various components of a system. So here the data bus comes, which will understand the main type of a data, which type the data is belonging to, and it will address the data which location it has been stored, and it will control the data where it has to be transferred again. Hoping that you are getting my point. Now coming back to the input output unit, you can observe the keyboard over here, which is nothing but the input unit. It will receive the input from the user. It will receive the input through the keys that is situated in a keyboard. We will give the instruction using the keys, and the monitor will display the output. So it is a output unit. This data transfer is done in between the input and output unit through the communication channel is called as cable. So this is which type of a cable? It is a USB type of a cable. So now coming to the ISA, stands for instruction set architecture. It refers to the set of instruction the particular CPU or a microprocessor understand. For example, if I write a program for adding two numbers, also subtracting two numbers, division, multiplication, etc., and if I use AND, NOR, NOT gates, everything in a set of instruction, the CPU will first analyze the capacity of every single instructions. For example, as you can see now, if I pass certain instructions, say as I1, I2, I3 and I4, and every instruction that holds individual capacities like I1 holds 30, I2 10, I3 50 and I4 5. The CPU will now analyze which one to execute first. The CPU will always execute the shortest instruction at the first. I hope you got my point. Now guess which instruction is being processed first. Of course, the I4 will be processed first, later on I2, then I1, and later on I3 will be executed. This set of instruction processing will be done using several dimensions like class of ISA, memory addressing modes, etc. For example, class of ISA means it will emphasize the instruction based upon how rich the complexity of the program is, how simple the program is, how efficient it is, how very long the instruction is. So based upon that, the bandwidth or the capacity of instruction increases, and the CPU will decide which one to execute first. Also, it will check for memory addressing, on which location the data is stored, which can be fetched easily or priorly, and addressing mode, whether the instruction is being registered in a CPU or not, or yet to be registered. This kind of addressing will be analyzed. Also, type and size of operands it will fetch for, like data type of operand. For example, if I take this simple program of any languages, on the first I have given a header int of a, b. I have defined the data type of a and b, that is integer, where a holds the value 10, b holds the value 20, and now I'm gonna perform the addition operation, that is sum. That sum is equal to a plus b, where I have used which type of operation over here? Addition operation. This can be analyzed over there, and finally the program executes. The result will be displayed on a system. That will be a control flow instruction. So register will be helping throughout this journey. Will also be helping to specify available register space in a CPU for execution of that particular program. Moving to the next slide, which is nothing but the design of a computer architecture. For every architecture there must be a design. For computer architecture, there is a design based upon these criteria. For example, microarchitecture is the first one. This level of a process, this will depend upon how must be the organization of a CPU should be done. Also, the components should be arranged, and the core, cache size, everything will be included over here. You can observe the pipeline depth over here. What is pipeline? The data flow will be continuous or simultaneous during data processing. The first is microarchitecture. Will be designing the micro components organization of a CPU and the cache and the number of the cores inside the CPU, hierarchy of a pipeline depth, everything. Next comes the memory hierarchy. It will be based upon the type of a memory technologies that is used, such as RAM, cache, virtual memory. What is virtual memory, by the way? Virtual memory is the imaginary memory designed by CPU during the process of data. That we will get to know in the coming up chapters. So the speed of the memory, capacity, cost, everything will be designed over here. And also parallelism and pipelining. Parallelism means certain instruction will be holding the same capacity. Those instruction will be processed parallelly inside the CPU. So pipeline in the sense the data flow will be continuously or the data flow will be simultaneous during the process. So it will not check for the capacity of instruction or a bandwidth or a length or a location it been saved. And comes the designing efficient input output system that allows the data to be transferred between the computer and the external devices effectively. So receiving the data also giving the output by processing the data for the user will also be designed in such a way that user should not be waiting for a long time for any execution of a program. Now power management, this is the main focus point we have to look after during the computer architecture designing. Nowadays it been implemented in a modern computer architecture also for modern processing. Modern process design also consider the power consumption and the heat dissipations, especially in a portable devices and data centers. This is the main focus of the computer architecture in a modern era, which should be focused on lowest power consumption, also the heat dissipations. Now comes the performance matrix benchmark. Performance matrix. Matrix in the sense it's a measurement. How actually the computer performs, it will be measured. We can understand that it's a overall measurement of a performance of a computer. That might be a low power consumption, memory management. Also, as we have seen ISA, the instruction set of architectures, etc. Let us see the components of a matrix and benchmark. And the benchmarks are tests performed by the cross-platform software. Let us see the components of a matrix and benchmarks now. Some of the matrices that we can observe in a computer architectures are execution time, throughput, latency, bandwidth, clock rate, IPC, cache hit rate, power consumption, etc. What are all they? Execution time is also known as the response time the CPU takes to process the data that been received by user and to provide the output. Throughput means the number of a task or an instruction that been completed per unit of time. Unit of a time means we will measure our typing speed in a words per minute or words per second measurement. Same way the task the CPU performed will be measured by unit per time measurement. The latency means it's a time taken for the data travel from the source to destination. How much time the data takes to travel from source to destination. And bandwidth is a rate or amount of a data that been transferred from one component to another component. Clock rate is a pulse rate the CPU holds during the execution of a program. IPC is the average number of instruction executed per clock cycles. As I already said, clock cycle is a pulse to synchronize the internal operation. The cache hit rate is a percentage of a memory access request fulfilled from the cache without accessing main memory. Without accessing main memory, how much ever the percentage the cache memory helped in a request processing. Power consumption is the amount of electrical power consumed by the computer system. And coming back to the benchmarks, they are spec, Geekbench, LeanPack, TPC, graphic benchmarks. The spec measure the performance of a CPU, compilers and parallel systems. So it measures the performance, how the CPU works, how the parallel system works, and also the compilers work. Geekbench is a popular cross-platform helped in the performance of the devices, processors and the memories. LeanPack mainly helps in solving the linear equations. It helps in measuring the floating point performance and the particular high speed performance. TPC provides the benchmark for measuring the performance of a databases. How the database performs, online transaction performs, how the processing takes place and the workloads takes place, etc. Graphic benchmark is nothing but the 3D benchmark. Helps in analyzing the performance of graphic processing units in rendering 3D graphics and games, etc. So here ends our first chapter of a computer architecture. Hoping that you have understood the topics. Whatever the doubts might be, you can post it in a comment section. Also, I'm super excited to know that which curricular background are you from? MSc, BSc, BCA, MCA, BE. Anything it might be, please comment your curricular background over the comment sections. If this session helped you, please comment session helped so that it will motivate me for upcoming classes. Hoping that you have liked the session. Somewhere in the video you felt it is helpful, please type helpful and hit the like button, hit the subscribe button and keep me motivated. Thank you for watching my video. Take care. Bye-bye.